How about this one? 2352 equal row and column pairs. Given a zero index n by n matrix grid, return the number of pairs R C such that the row and column are equal. Huh? Oh wait, yeah. You know what? I was already working on this one and I wrote that comment. Um so return the number of pairs whole rows and whole columns such that the row and column are equal. Okay. So what I'm thinking, so this is a hash map problem. What I'm thinking is um, just sum up all the rows and columns and then we could put them in a hash map. We could put them in two hash maps or one hash map with two arrays. And those two arrays would be the rows with that sum and the columns with that sum. Um, Actually, no, we don't even need. So we put them in a hash map. Sum up all the rows and columns. I've got syrup on me. It's breakfast. Put them in a hash map. The hash map key is the sum. The value is the row count and count call count. So it's the number of rows with that sum and the number of columns with that sum. Okay? So with that, we should be able to get the number of pairs. Now, what's the number of pairs you can make out of two things? There's a formula for that. Oh, wait, it would just be blank times blank. What am I thinking? Um, yeah, and then we just return all the products of the vowels. So if you have one row and two columns with the same value, that's two pairs. If you have two rows and two columns, that's four pairs. Okay? Cool. Yeah, let's do that. So, sum up all the rows and columns. All right, let's say um I don't know. What do we want to call the dictionary? We'll call it map. No, not map. That's a keyword. We'll call it line sums. And that's going to be a dictionary. And now just for row in grid. Do we want it to be a default dictionary? No, because we'd like to just go through all of the existing values. We don't want to go through values that don't exist. And that's the problem with the default dictionaries. It's harder to go through those values. Actually, can we do that? Yeah. I'll just use this. Okay, so for row in grid, um, we're gonna say, actually, are tuples mutable? I think they should be. For row in grid, we're going to say sum, no, total equals sum of row. So sum up all those values. And then we'll say if line sums in sorry, if total in line sums, then we're going to add that to the line sums. So the line sums total equals let's say counts equals line sums total. And now we'll say counts 0 plus 1 and 0 because we haven't gone through the columns yet, so we know there's not going to be any columns with that count. Now we're going to say for call in grid, we're going to do the same thing. But we need to sum it up in a different way. So we're going to say total equals, we can do this, sum of, I bet I can do this. It's the sum of grid R, we're going to have to do C in length. Why don't we take M and N? Oh, well, we know it's a, oh, so it's an N by N, so it's going to be the same thing. So N equals the length of grid. Okay. So we'll just gotta say for C in range N, total equals grid RC for R in range N. Cool. So this gets all the rows and then gets the same column value. All right. Now we'll say, oh, we also need to initialize the values. Line sums total equals 1, 0. And then when we go here, we'll just do the same thing. What's important is that we also hold on to the counts 1 plus 1. And if it's not in there, then you say 0, 1. Awesome. Do we even need to add it if it's not already in there? Because if it's not already in there, then that means that there won't be any pairs since there aren't any rows with that sum. So we only need to add the columns, the sums that are already in there. As if they're not, you saw me go through all three theirs. If they're not, then what's it called? If they're not in there, then they can't form any pairs, since we already went through all the rows. So now we just say for val in line sums values, we'll say total pairs equals 0. For val, we're going to say total pairs plus equals val 0 times val 1. And then return total pairs. Does that work? Wrong answer. How did I count 3 pairs? Let's just put a breakpoint here so that we can see the line sums values. Okay, so we have the grid. Okay. So we have one line that adds up to one row that adds up to 6 and one column that adds up to 6. That's true because 3, 2, 1 and 3, 1, 2. Okay. It says we have one row that adds up to 14, which is this, and then one column that adds up to 14, which would be I might need to type this out. No, one column that adds up to 14, which would be 277. Nope. I feel like maybe I just didn't read the question right because those do add up. Because 277 is a column and 277 is a row. So what am I not reading right in the question? Return the number of pairs such that row I and column J are equal. Oh, same elements in the same order. Why did I? Oh my gosh, Kyle, you didn't even read the question. Kyle. Oh, come on. Read the question. Honestly, like above anything else, so many of my wrong answers have come from just not reading the question right. Um, okay. I'm gonna reset the whole thing. I'm so silly. I thought it was the sums. It was actually the values themselves. So we're just gonna say n is the length of grid because it's a square. It's n by n. Um, Now we'll have two. Okay, so ooh, okay, now that's a good one. So an array, same elements in the same order, an equal array. Well, we only had to go through the rows, and then for every row, you could compare it to just all the columns. But that would be like O(n) time. And it would also be really long. Give me a hint. What? Yeah, that's what I was saying. But I thought that would be too long. So Should I get the hash values of all the tuples? So like for row in grid. What if we just take the thing before, except instead of the sum, we say hash, or we'll say h equals, could we say hash of the tuple? Or what if we just did tuple? We'll say t equals tuple row if t in sums. Would this work? If not, we'll just try hashing it. Hey, it worked. Submit. Woo! Hey, that is good to know. Okay, my question is, will it run faster if we hash those values? Let's try running that. That's great. Okay, so that's a great problem, and it's a great problem because it taught me some valuable things. So here's how we did. Here's what we did. The problem, in my opinion, with doing the things the hits go towards is that that's going to be pretty costly to compare every single value of every single array. Now, sure, you could just stop the comparison once you notice a difference, but I'm sure that there's an edge case where, you have a grid that's really big and you're going up to the end, and then at the last second it becomes different. So you had to compare all those values. Or even, if they're just the same, you still have to compare all the values. So that would be kind of costly because for every row you'd have to compare it would be O(n) squared, which if the grid gets big, which it does, no, wait. Oh, the grid actually doesn't get that big, but still, this is way faster. So, because O(n) squared would be 40,000. So what do we do instead? Well, we basically just do what I thought it was with the sums, so it's a valuable lesson. And we say, okay, so we have this little map, and this map keeps track of all of the rows or columns that have the same hash value. And the hash value will take the array and through the hash function convert it into just one little key number. That will only happen if all the values are the same. And so we can just use all those hash values and then increment the counts of the rows and columns that have that. We can also ignore a column if there's no row that already has that hash value, because otherwise at the end because there's no pairs for that. And then we just accumulate the pairs by multiplying the number of rows and the number of columns with every single hash value. Great problem. Bit of a boneheaded mistake at first, but I actually think it worked out because, because basically it's just the same thing I thought it was as a sum, but instead it's for hash values. Hash values. That's all it is.